it's like my first time, so I
Okay.
kind of want to like figure out where my level
Yeah,
is
totally. Yeah,
and
that's totally chill. Um,
things to
your
improve
first
on.
time
Yeah, yeah,
doing a mock, right? Not first time doing Leetcode. Okay.
yeah,
Okay,
yeah.
my first
Right.
time to Leetcode medium's pretty serious. I respect it though. Um, okay, cool. Let me see. What problem should I give you? Okay, I can give you a fun one, or I can give you not a fun one. Do you want a fun one or not a fun one?
It's up to you.
I'm trying to find one that's not too unfun, but one that's still decently fun. Um, okay, you know what? Let's do this one. I like this one. I like this problem a lot. Okay, so I want you to implement a function called power.
Yeah,
Okay, and by the way, yeah, this will be a general lead code
power.
mock interview. So what's going to happen is that we're going to do the mock, but unlike a quote unquote real interview, that you can pause and ask for clarification on that jazz as you would, and you can also ask me for if you need a
Hmm.
hint or something. If you feel like you're stuck, if you feel it's wasting your time, then just feel free to stop me, ask me for
Yeah.
clarification, etc. That's all good. Okay, yeah. So for this
Okay.
problem, we're
Cool.
gonna be implementing
Cool.
a function called power. It's going to take two inputs, x and in. Okay, and
Okay. So
yeah,
inputs are
yeah, and x
X
is going
and
to be
then
a float or double, or what's it called in C++? A floating point, a double
it's a
position floating
float.
point.
Yeah.
And in is going to be an integer, can be positive,
Okay.
negative, or zero, any valid integer in C++, right?
Okay.
And I want you to return me a floating
Okay.
point, a double position floating point that is equal to x to the power of n. Yeah.
X to the power n. Okay. Okay. So wait, I think this is it's gonna be a double. So our output would be essentially like x raised to
Yep.
the power of n. Yeah. This would be a double,
Double
right?
position. Yeah.
Okay. Okay. Just to clarify some like some questions. So yeah, I think you mentioned before that x is like literally any possible number.
Yes, x can be any possible number.
So in terms of like the yeah. So it could be like would it can like fit within I guess what is it like 32 bits or something from like negative all the way to positive.
For x, yeah, x can be. In this case, we can say
Yeah.
x is it's the base, right? So it can be any number. Yeah.
Okay. And then n is it could be negative 0 or 1.
Yes, n can be.
Okay.
Yeah.
Okay.
So yeah.
Okay. So okay,
Also the
cool.
full integer range.
So I guess
Also,
sorry.
n can be the full integer range. So both these numbers can be the full range of their. Yeah. But for the sake of argument, yeah.
The full
So n can
range.
be any number from negative
Yeah.
two to the in C++ it's 32 bits, right? So 2 to negative 31 to
Yeah.
positive 2 to 31 minus 1. Yeah. And we can
Okay.
assume
I see. Okay.
and we can assume that the
Sounds
output
good.
fits inside of a double. So you can assume that.
Okay, cool. Awesome. Okay. So I think right away what I'm thinking is we can do this I guess recursively based on a couple of like decisions we can make depending on whether like n is like a negative or positive. So let me
Okay.
just write that out. So I don't really know the format to do it, but I guess so let's say n or like case one, right? Um if like case one is if n is 0, right? Then our output um would just be 0, right? If I remember correctly. And then if for case two, if n is positive, then we can just do x to the power of n.
If n equals 0, the power equals 0, then it should equal 1.
Or is it 1?
It should be 1. Yes,
Is it
it should
1?
be
I
1.
think it's
Yes.
1, right? Yeah. Yeah, like yeah, two part yeah, 1. And then case three is if n is a negative number, so if powers are a negative number, then it would be 1 divided by x to the power of n, right?
1 divided by x. Yes.
So I think we can like split it. Yeah. So I think we can like split it into these three
Okay.
cases, and then we can have like some kind of recursive like function to compute x to the power of n.
Okay, yeah,
right?
we can. I mean, you need to go into more detail, but that's a good start.
Yeah. And then in terms of how we would do x to the power of n is I think as we're so I guess at each step, um so let's just have like an example, right? So let's say like 2 to the power of like 4 or something, right? It's really just 2 times 2 times 2 times 2 4
Yeah.
times, right? Yeah. And then the way we can break it down recursively is it's really just like 2 times 2 to the power of 3, right? And this is essentially like that recursive
Okay.
call we're
Yeah.
making. And then we can break this 2 to the power of 3 down recursive as well. So it becomes 2 to the power of 2 to the 2, and then
Yeah.
so on, right? And then we get to
Yeah.
this last step. So I think we can like
Okay.
start from there.
Yeah,
Does
that
that
makes
kind of
sense.
make
Let's do it.
sense? Okay. Okay, awesome. Okay. So our function signature would be we're gonna take a double and then an int n. And then if so once again, if n is 0, then we can just return 1. If it's positive, then we can return so we're gonna have a recursive function called power like that. And it's gonna be like that. And then otherwise, if it's negative, we can return 1 over this. And it would be negative n because you want to flip it to positive. Does that kind of make sense?
Yep. One thing I want to ask is,
Mm-hmm.
which I don't think I'm not sure if you said explicitly. Does the sign of the x matter? Not saying it does. I'm just wanting to be specific about that one.
The sign of the
Yeah.
x.
Yeah, like the positive
Um,
negative.
yeah, it should
Yeah.
matter actually. Yeah, it should matter because if we're doing like negative 2 to the power of 2, then that would become positive, right? But if our exponent is what do you call odd, then I'll keep like the original exponent or the original sign,
That's true. Yeah. Does your
right?
implementation respect that, or are we gonna look at that later?
I think maybe we could like implement that into our like recursive function.
Okay. Yeah. Just as long as you considered it, that's good.
Yeah, yeah, we'll consider it later.
Yeah.
I
Sure.
think at the end or
That's good.
something. So yeah, so our power function would have once again double x. Let's write our base case. Our base case is if um, n is 0, right? So if n is 0, then we can just return 1 because we're multiplying. Because I think eventually like this 2 to the power of 1 and then 2 to the power of 0, we would multiply this by 1 at the end, right? So I think that's our
Okay.
base case. And then for the case that and then isn't our recursive call, wouldn't that be like let's say our res is would be x, and then we would well x would be let's see x would be x times the power of x and n minus 1, and then we can just return it.
Okay.
I guess we don't even need like this part. Does that kind of make
Yeah.
sense?
So your base case is n equals 0, and you're decreasing n by 1 every time. Okay.
Yes.
And because your n is always positive, since you're inverting it if it's not. Okay. Yeah.
Yeah.
That's fine with me.
I mean, I think this way it like the original question where like the sign of x, I think this would preserve like the sign of x
Yeah, because you never invert the x. Yeah.
because yeah, exactly. Yeah.
Okay. Do you want to write a quick test for this one?
Yeah, I think we could do we can just do let's say power of let's say 2 to the
Mm-hmm.
4. So once again, we have so n is positive in this case. We'll go here, and then we're gonna go into this recursive call. Um, and then we have x would be equal to so 2 times this power function. So 2 to the n minus 1, which is 4 minus 1, so that's 3,
Yep.
right? And then um, into like this recursive function, we could break that down to once again 2, because that's x to the power of or times sorry 2 to the power of 2. Oops, like that. And then we kind of keep on going until we get to this would be 2 times 2 to the power of 1,
Mm-hmm.
right? And then there's going to be one more call, which we'll get to 2 to the power of 0. And then this evaluates to 1, or yeah, because that's our base case. And then we'll get what?
Yeah, makes
16
sense.
here.
Let's talk a little bit about the
Yeah.
time and space complexity for the solution.
Yeah. Okay. In terms of I think time complexity wise, I think it would be because at every recursive call we're just subtracting
Mm-hmm.
n by 1 all the way to 0.
Yep.
So I think time complexity wise it will be like O(n),
Okay. Yeah.
right?
Okay.
And then space would just be the recursive call stack, which I guess it's also O(n).
Mm-hmm.
And we're not using any like extra data structures. So I would say it's just these two in terms of time and space.
And x here doesn't play a role at all. The
Sorry?
x here, so x is an input, and doesn't so x does not affect the complexity at all.
I don't think X would affect complexity.
Okay, that's fine. Let's talk about why
Yeah.
is this thing? Oh, because it did declare it after as a C++ moment. Okay, cool. That's fine.
Yeah.
So I'm in agreement so far. I want to talk a bit about how we can improve this algorithm.
Mm-hmm.
So we can
Okay.
start with the easy one of improving the space complexity. We can, but I do want to
Yeah.
hit the main problem, which is how can we get the time complexity down. So do you have
Okay.
any intuition
Great.
for either of those improvements so far?
In terms of, so you said that the main one would
Yeah,
be
the goal
time,
is to
right? In
reduce the
this
time complexity. Yeah.
situation.
But there is a pretty easy optimization you can make for space right off the bat,
Yeah.
but that's not the bulk of the problem.
Okay. Okay. Sure. I think for time is because it seems like as I write out like the as like or
Mm-hmm.
execution up here, there seems to be like some repeated work, right?
What kind of work?
Because I could see like how yeah, because notice how we're kind of just multiplying two like a bunch of
Mm-hmm.
times,
That's
right?
all.
So I
Yeah,
think
that's all exponents, right?
yeah, yeah. I think that, instead of actually like decreasing or decrementing n at every like recursive call, I think we could I'm trying to think of how to like express this. I think like there's something we can do to like decrease it by like a bigger
Yeah.
amount. Like, do you get what I'm kind of
Yep,
saying?
that's the only way to decrease the time complexity, right?
Yeah, yeah,
If
yeah.
you decrease it
So
by
I think
if you decreased n by a fixed number such as one every iteration, then you have O of
hmm
n time complexity, right?
hmm
So you need to do better than a
exactly,
fixed
yeah,
number.
yeah. Okay. So I guess the only other like operation we can use to cut down on n would be like dividing n, I guess, right?
That's one of the ways you can do it, not the only way.
Yeah. So um not the
I mean,
only
there's
one.
also log
Okay, well, I
that also decreases
oh
it.
yeah, there's also log, but I think in the context of like we're doing powers, I think if we let's say if we like let's take the example of like two to the power four,
Mm-hmm.
right? Um why don't at like let's say at or let's say let's do five to make it like bigger.
Mm-hmm.
If we okay, hold on. So back to four, or let's say like eight, something bigger. This is equivalent of let's say two to the power of four times two to the power four, right? Or sorry, times like that, right?
For 8, yeah.
So I think yeah, those are like
Yep.
exponent rules,
Yep.
right? So if we cut down,
No,
yeah,
no, no,
sorry.
it's good. Yeah.
Okay. So we actually cut down our like our exponent by a half, right? That just means we're multiplying like these two together.
Mm-hmm. Yeah.
And I think there's something there, I think. I feel
Yeah.
like um yeah, so yeah, so then we can like break it down like this, right? And then similarly for two to the power four, we can also break that down into like two to the power of two times two to the power of two, right? And then of course the same thing would occur for like uh, this four right here,
Yeah.
right? And then I think that like that kind of cuts down on like the time complexity.
And what's the base case?
The base
Yeah.
case,
So when do you stop?
I think the base case would still remain. Yeah, I think the base case would still remain. Is when what do you call when n is zero, right? Oh, but if we go down one more level, we get one here, right? So I think um then how will we get from like one to zero? So let's see. So I think if the exponent, right, is a odd number, so like one,
Mm-hmm.
three, five, we can just kind of do it this way where we just like decrease the exponent by one, and then once we get to like an even number, we can actually like divide the exponent by two. Does that kind of make sense? And that's how we would reach like our base case, so like to the power zero.
Okay. Yeah.
Yeah. Is
Yeah. Sure.
so do you think that works, or
Yeah, that
like
makes sense. What's the
what are you
what's the
saying?
time complexity of that going to be then?
Like time
Yeah.
complexity of this? I think it'll be since we're dividing by two, it would just be log n, right?
Mm-hmm.
We're dividing n by two.
Yeah. Okay.
Yeah.
Yeah. Let's go ahead and implement that.
Yeah. Okay. Right. So over here, so I think we need to check if n is even or odd, right? So let's say if n is like, let's say odd, then I think we can just like return this bar right here, right? And then if the other cases of if n is even, then what did we say we do? We would cut down the exponent by half, but then we would multiply the base together,
You're right.
right? So it would be just be x times x and n divided by 2, like that, right?
X times x. Well, what is x is a base?
Mm-hmm.
It's a base squared.
Sorry. Yeah, base squared, right? Because we're actually multiplying like these two together as we're going like
I see.
up the stack.
Okay. Sure. Yeah.
Yeah. Because we start from here and then we'll go up and up to get the answer.
Yeah.
Does that kind of make sense? Yeah. Yeah. So once again, like space time complexity would be log n, because we're dividing n by 2, and then equivalently, the space complexity is also bounded by the stack, which is log n.
What's the Yeah. Is there a consideration for another? Yeah. So I agree that in general it's gonna be log n. However, is it still the case when there
Yeah.
are, for example, there's a path of dividing by 2 and subtracting 1 where it traverses through many odd numbers? In that case, would it still be considered log n?
I think so let's say we start off with like an odd number, right? Once we like -1 to make it even, it'll be all the way even, like the whole way, right? Because even divided by even is even, right?
Not
So I
necessarily.
think at
Even by
most,
even, 6 divided by 2 is 3.
yeah. Oh, 6 divided by 2 is 3. Okay, right. Let's see. Right, so 6 divided by, so let's say 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And then once we get to odd, well, -1, so it's 2. So I guess, like worst case, I think it would be like at most half, right? Like half those iterations would have like odd powers.
At most half. Yeah. Okay.
Yeah.
And so therefore,
So therefore I think like space would still be bounded by like the subtracting one. So it'll still be like n, I guess.
okay. So the space, so the big O complexity then.
It'll be like on, yeah.
If the and the reason, and you're saying that's on is, and you're saying that's on because it's bounded by the subtraction. If that's correlated with the height of the tree, would the time complexity still be the same, or would that also be on? Well, like, what's the difference between the time and space complexity in this case? Is the other question.
You're right. I think it should be like bounded by the time, or like the time and the space should be. I think it should be the same.
In that case.
Because it's bounded by the height of the tree, right?
Right. Yeah. In that
Yeah.
case, would it be, well? So which one is it then? Is it log in or in? Is a question.
Yeah, I know. I'm
Okay,
trying to
yeah.
think. I feel like gut feeling, I'll say is log n. I feel like it's
Okay.
log n because I think like dividing by 2, just kind of like powers over -1 in terms of like the height of the tree. In terms of like I guess like a mathematical proof or explanation, I'm kind of unfamiliar with that. So I don't think I can come up with like a mathematical proof or
That's fine.
something.
Okay. Um,
Yeah,
okay. Yeah, that's fine. That yeah, that sounds good.
yeah,
We
yeah.
went through this problem pretty quick.
I do want to say that.
Go no, go ahead. Go ahead.
Sorry, yeah, yeah. I do want to say that. Like I know the constraints of like what x and n can be could be like we didn't really like define it. So I think there are cases where like if we try to like let's say like and in this case is like the minimum integer in the 32-bit range, and we try to like multiply by -1, it might like overflow or something like that. So I think
Mm-hmm.
like based on like what we define the constraints are, we can probably there's probably like some edge cases with like overflow and
That's true.
stuff.
I avoided that by just saying that the output
Yeah.
fits in the solution, and if the output fits the
Hmm.
solution, then
Yeah.
you cannot under
Yeah.
overflow. But yeah, it is true. I think in the
Right.
regular Leetcode problem as well, I don't think they have any edge cases like that because I think x only goes from negative like 10 to positive 10 or something stupid. But um,
Hmm.
okay, but that's not the
Hmm.
focus of this problem specifically. Okay,
Right.
we went through the base problem pretty quickly. There is and usually they won't give you an option here, but because this is a mock, I want to give you the option. Would you prefer to do
Hmm.
the super math focused optimization, which I don't really recommend, but is something I've seen in the past where really evil interviewers want to check your bit math? Or would you rather do a separate problem, which is typically going to
Um,
be more interesting, but is not related to this?
I would prefer a different one
Okay.
because I feel like I really don't know like I don't think my math
Okay.
is like
Yeah.
that
Yeah.
strong.
Okay.
Um,
Yeah. Let's move on.
yeah. But in terms of like yeah, but in terms of like the way I explain this problem, well, like what do you think about it? Because I feel like there's like areas
Uh
where
huh.
I feel like I didn't really get the point through.
Let's go through that
So
feedback
I
at
kind
the
of want to
end.
see like
I'm not talking about both. How's
okay,
that sound? Okay. Great.
okay, sure,
Okay. So
sure,
let's just go
that's
to the
fine.
bottom here and let's just continue.
Yeah.
So don't delete anything above. So we just continue here. Okay. All right. So
Okay.
the second problem here, I'm going to
Yeah.
give you. Let me just quickly think about what's going on here. What is this? This one. Okay, great. Yeah, so this is going to be about navigating through a grid. Okay, so we're given it m by n grid. That's m by n. Okay, and it's going to be filled with integers,
Yeah.
positive. Okay, and
Okay.
our goal and we're start on the top left coordinate, and we want to go to the bottom right coordinate. Okay, and we want to make this traversal. And traversal in this case only means up and down, so you cannot go diagonal. Okay.
Okay.
Yeah,
Go
up and down.
up
So, oh, sorry.
and
Right,
down.
right, and
Okay.
Bottom. Sorry, I got that orientation. It's right. Yeah,
So
right,
right
and
and
down.
down.
Yeah, right and down. So you
Right.
can't go up
Okay.
or left.
Yeah.
Okay. So
Yeah.
those are
Okay.
only valid loops, and the goal is find a path with the lowest sum of the points.
The lowest
Lowest
sum of the
sum
points.
of the path
Okay.
where the sum is just because every square has a value, has an integer, positive integer. Find a path with the lowest
Hmm.
sum of all these positive integers.
Yeah. Okay. I see. Okay. And would there be is it possible if or you said positive integers, right? Okay.
Yep.
Okay. Let me just think about it for like a
Yeah, for
couple
sure.
seconds. Hmm. Okay. I think that well the brute force way to solve this problem is to literally compute like all the possible paths and then just choose the one with the lowest sum, right? Because you said we want to
Yeah,
minimize the sum.
minimize sum.
Yeah. So I guess we could do something again. I think we can do it like recursively, where we start from the top left, and then we go all the way to the bottom right, and then compute that sum, and then we take like the min between either going down or right.
Yeah, we could do
Um,
recursively. Yep. Yep.
yeah, yeah. So I think that's like the most brute force way. Um, do you want me to start with that, or we can like maybe discuss? something better.
Do you have intuition for what might be better?
Um, let's see, intuition.
Yeah. So.
I think we could do something where as we're iterating, like let's say left to right,
Uh huh.
top down. So we first go left to right, and then we go,
Yep.
top to down in that kind
Yep.
of order of the grid. We keep track of um, we kind of keep track of like the the maximum or the minimum values between like I guess in reverse, up and left, something like that.
You can try the minimum.
Does that kind of
Sorry,
make sense?
you can
Or
try the which value?
so as we're like iterating
Uh
over
huh.
the grid, um, like from left
Yep.
to right, top down, we can use the values that's above
Uh
it
huh.
and to the left to kind of compute the minimum between those.
Yeah.
That's kind of like a very basic high level intuition.
That's a good intuition.
What do
Let's
you
try to
think?
implement that. Let's try to implement
Yeah,
that. Yeah.
implement that. Okay. Okay. Yeah. So I think maybe we should probably start off with like an example.
Not a bad idea.
So let's just say, yeah, let's just say I have oops, our grid here. So let's say, to keep it simple, I'm just gonna have, let's make this like 2 by 3. We'll change these numbers later. I'm gonna set it up. So we're
Mm-hmm.
starting from here. Oops,
Yep.
from here. I'm going to the bottom left
Yep.
or bottom right. So I think um let's make some numbers here. So let's say this is 2. Let's add some zeros. So
Okay.
something like
Yeah.
that,
Sure.
let's just say. Yeah. So as I mentioned before, um, we go left to right. Or I guess it's a more intuitive to start from the bottom because that's where we're trying to reach, right?
You can go.
So we
You
can
can
be
go
like,
either
okay,
way. Um, when you said that
yeah,
you're tracking the minimum, right? The minimum path from top left to bottom right is the minimum path from bottom right to top left. So it doesn't actually matter. So it's up to you
yeah,
however you want to think
yeah.
about it. Yeah.
Okay, okay. So let's start from like the bottom right here, right? So we can go either left or up essentially in reverse. So we can be like, okay, at this point, the minimum at this point is just 1, right?
Yep.
And then if we go, I guess in this case we're gonna go right to left, down up. So at this point, the minimum would just be this one plus the current one right here, right?
Mm-hmm. Yep. Yep.
And then once we go here, the the minimum would just be um well, we have to add this like everything from this point on. So that would be kind of like 2. So it should be
Yep.
like 2. And then, this would also be 2. And then from this point, um, it would be 3, right?
Yep.
So maybe I'm gonna have like another grid just to kind of like show you like the updated values. So once again, this is 2, 2, 2, and we're at here. The minimum value is the current one, so this would be
Mm-hmm.
3. And then once we get to this point, this is where we decide, do we want to go like right or left,
Yep.
right? So it will be like the minimum between like the current value. So I guess this is kind of like dynamic programming. So DP at like let's say IJ and um sorry,
So
it'll be
you're so,
I
so you're at
minus
3 right
one.
now, right?
We're
Okay, yeah.
there, yeah, we're there. Yeah, it'll be the minimum at I plus one, sorry, so
Down.
that's
Yep.
down. And the minimum at the current row, but the one to the right, plus the current number.
Yep, that looks good to me.
Like, oh, it wouldn't be DP at IJ, it would be I guess the grid at
Yep,
IJ.
that's right.
That's kind of like the formula, I guess. Does that
Yep,
kind of make
that looks
sense?
correct to me.
Okay. Um, so yeah, I think we can just do this. And then at the end, we can just return, what? We can just return our DP array at 0, 0, kind of thing.
Okay.
And then in terms of like time and space for this, it'll just be it'll be m times n for time, and also m times n for the space because of our DP grid.
Yeah.
Yeah, okay. Okay, I'll start implementing it. So we have let's see. We're writing what's the well, let's say min sum. We're gonna have 2D grid of integers. And then yeah, I think that's just the function signature. Let's initialize or let's have the sizes of our grid first. Let's also assume that, or is it the grid be like empty?
No, you can assume it's a good faith input.
Okay, yeah. So yeah, the sizes, and then we can initialize our DP array. This would be two-dimensional, so it would be m plus n or m plus 1
Yep.
because we need like a row and a column for the base case. And then same thing for the columns. And then we can initialize the default value to be I guess like a really big number. Like let's say like in max or something.
I mean, in
Yeah.
your method, you'll overwrite every value of DP anyways.
Yeah, I
So the
will
value of
overwrite
the
it. Yeah,
DP
yeah.
itself
That's
doesn't
true.
matter,
That's
but
true.
that's fine. Yeah, that doesn't matter.
Yeah, yeah, yeah. That's true. That's true. And then I guess for our base cases, um, well, technically, when we're doing it, we want like another row, I guess, at the bottom. I think it should be so. Well, if this is if we initialize it to like infinity, right? Then if we do the min between, oh sorry, this should be DP. The min between like the one below it and the one to the right. So yeah, I think initializing to like a big value would already like cover the base case
Yeah.
here.
Okay. It would have to
Yeah, yeah.
is this n plus one already one bigger than the original one? Is that how it works? Like if you want, yeah, like if you
One
want your
bigger than the
DP to
original one?
have one more row and column,
Yeah.
is this like does this account for that? Is that how you do it? Okay.
Yeah, yeah, that's how we count for it.
Okay.
Because if we do like in this example, it would be what? It would be 4, right?
Yeah.
So then we would have indices 0, 1, 2, 3.
Okay. Yep.
Yeah. So let's do it this way. So int our row, we want to start at the last row, but not like this row. We want this row,
Yeah. Yeah.
right? So it'll just be m here, and then sorry, m minus 1. Um, and similarly for the column, we'll start at n. We'll start at n minus 1.
Okay.
Like that. Now let's see here. So dp at the row, the column, is going to be equal to the minimum between our dp array at the row below it and the column beside it, so to the right, and then plus our grid at RC, like that.
Okay. Yep.
And I think that's about it. And we can return our answer, which is the top left, because we're doing it in reverse. Yep. Yeah.
Okay. Let's go to the time and space.
Yeah. So the time complexity is we're looping over the grid, so just that's m times n. And then for space, we're using like a dp array of size, basically the grid, so that's also m times n.
Was there? Yep. So I agree with that. Is there a way? So one thing I wanted to ask is, in this case, I didn't. I guess it didn't say whether or not you were allowed to overwrite the grid or not. If you were allowed to overwrite the grid, would you have been able to save the space complexity, the extra space?
The extra space? Yeah, actually we can, because this formula means we're only looking at the current row and the row before it, right? So that's technically we only need an array. So the current like dp row, and then like our previous dp row. So let's say just to keep things like consistent, we don't want to like change the input grid, right? We can have like, as I said, we initialize 2 arrays, right? And then I guess at the end of processing like a row, we can just swap like the previous one and the current one, like that.
Yeah, that's fine. And what would that bring your time complexity, or I mean space complexity down to?
Yeah, it'll bring the space to the amount of columns there are, so it'll just be n, because we only have 2, so that's constant. So it's 2 times n, so that's n.
Yep, makes sense.
Yeah.
Okay, let's pause here then. I'm happy with the progress, and let's go over some feedback. So just before we kind of get to that, I want to ask you how you felt about the process, how you felt about the strength of your solution, etc. And if you don't have any thoughts there, then I can talk a bit about it, about the process.
Yeah, I'll talk about how I feel about it. I feel like in terms of getting the solution, I think I could do it like in my head, right? But I'm kind of unsure if I'm like explaining it in a way that you might understand, right? Because as I said before, this is my first time mocking, so like all my other practice is just like me alone, right? Doing it like in my head. So I'm not sure that I like communicated it like properly.
Okay.
So that you can follow along, right?
Okay. A couple of things there I think we can get started on then. So first of all, that's sort of like the main thing that people need to practice for mocks, right? It's not necessarily the algorithmic ability, you can do it yourself, right? It's about communicating. So let's get into that. So back to that first problem. Let's talk about that one first. Obviously, I think this is a pretty strong performance for both problems. These are both about, I'd say, easy to medium level, medium questions, like within the medium category, easy to medium, that kind of range. Couple of things first. Good clarification of problems, good intuition for the initial solutions. I will say though is that I think at least for clarifying the problem statements, it's good that you're fast at writing notes and fast at coming to the initial consensus. it definitely helps to write the test cases early on. And the reason I say that is
Okay.
because, well, there's a couple reasons. The first one is because it's like an insurance policy to make sure that you and the interviewer agree on the same outputs, right? So it's always a good thing to do. And the second thing
Definitely. Yeah.
is it's a bit of a time management technique, right? So for example, it's one thing to ask to interviewers is, hey, and this is in general, this is not just for tests, is, hey, what level of code am I expected to write? Like, are we expected to write fully runnable code? Are we doing? I mean, these days no one let you write pseudocode exactly, but how far down the scale are we doing? Because I mean, in this case, there was
Right.
obviously you're familiar with C++. That was proficiency there. I'm not concerned about that. But for example, if there were things like such as a math problem where let's say a GCD was involved, and oh, can we use the built-in? Can we do that? Can we do this? Oh, can we do the prime thing, etc. Right. That just helps establish early on in the interview what level of detail we're going for. So it's
Hmm.
good to just kind of clarify that ahead of
Hmm.
time. That's kind of the first thing. So
Okay.
that plus examples. Another thing I will just slightly touch on is that some interviewers will actually ask you to write runnable tests, depending on the situation. So like runnable code and runnable tests. So just make sure you're aligned on that
Uh-huh.
one because sometimes it is a case that interviewers will specifically ask you to run the test just so they can check the solution, right? Usually not for
Okay.
questions
Yeah.
this simple, to be honest, but for some more complicated questions, they might ask you to write some tests because they might not have seen or fully understand your solution for the problem. Okay.
Hmm. Right.
Communication wise for this problem, I think overall was quite strong. It was a good intuition for the basic case. One thing I will say is that at your level, you should just directly ask to implement the optimized case, assuming you thought of that, because it's generally a bit of a generally a bit of a time sink. It's a bit of a waste of your time to implement the base cases. I'm sorry, not the base case, the basic versions of the problem. So if
Okay.
after you write the test and you understand what's going on, you can think of optimization and you're relatively confident in it, then you should just ask directly if you can go to that solution. Because if it's a question at this level, then you're
Okay.
wasting your time doing anything else, frankly. I mean, in
Right.
this
Okay.
case, it actually wasn't too bad because you were able to reuse a lot of the functions to implement the optimized solution,
Yeah.
but
Yeah.
that won't generally be true. So just
Yeah.
be aware of that.
Yeah. But the thing is, like, at that point, I wasn't like a
Yeah,
100% confident if I was able to like produce something
then that's fine.
optimized, right? So I felt like I wanted to write like
Yeah,
something down at least.
yeah. I mean, like, in that case, then what you did
Yeah.
was perfectly fine. I just wanted to let you know that, like, if you are
Hmm.
operating at this level and you get asked to use your medium or something, and you can stretch for it, then I would say go for it. Because for
Okay.
typically
Yeah.
speaking, for an hour interview at the top companies, you would get at least two questions of this difficulty and follow-ups.
Yeah.
So that's kind of the idea there, right?
Right. Okay.
Um, by the way, so we didn't have time for the follow-ups
Okay.
for the second question. Generally speaking, there's going to be follow-ups for every question they ask, and it's just a matter of do you get the or
Hmm.
not. So just be aware of that. Cool.
Right.
Okay.
Okay.
So that's fine. Yeah. So the communication part on the power question, right? Like what is going on with the time and space complexities. So it is pretty. By the way, it is correct that it is log n. But you kind of got juked out there,
Hmm.
and I think that really just comes
Yeah.
down
Yeah.
to two things, right? The first thing is, like, the first thing they're trying to test is they're testing your confidence in your answer, right? Because because if you
Right.
correctly say
Right.
it's log
Yeah.
n, and if by prompting basic questions like where's x, what's the height, does -1 do anything, that cause you to switch your answer, then you aren't very like confident in your answer, right? So that's part of the communication
Yeah. I
process.
agree.
And now specifically, what is going on with this problem is it's testing two things. First of all, it's testing do you know some math. Now obviously the first math is do you know the exponential rules like multiplying two exponents of the same base, you add the powers, right? The other thing they're really testing about
Hmm.
is how strong you are in actually understanding the recursive case. And I'll give you an example of this, okay? So in the original solution you produced, which is like so roughly
Yeah.
here, where is it? Oh, it's gone already. It doesn't matter. So we usually set the space complexity for the original one was O of n, right? And it's very easy to think what that is. It's because
Hmm.
you think, oh, the call stack is going to be in long because we have in recursive calls, right? That's true,
Yep.
except some languages, not saying C++ does, but some languages have what's called tail recursive optimization. Are you familiar with that? Okay, so go
No.
read that later after the fact. Basically, if
Okay.
if the last call in a function is a recursive call, then it uses constant space. And that is
Oh,
because
okay.
I'm not sure what
Okay.
kind of CS background you have. It doesn't really matter, but there's a pretty famous lemma a theorem that states that all recursive calls can be implemented iteratively and vice versa, right? And this
Yes.
function, if you think about
Yes.
implementing it iteratively, it's trivial to use fixed memory, right? You literally just loop it, right?
Yeah.
So it's actually not
Yeah.
true to say that, oh, it's linear memory because it has this many things. That's generally true, but that's not always true. So
Mm-hmm.
that's a piece of thing which they could have picked you out,
Mm-hmm.
right? So just be aware of these kind of things. That
Yes.
they're
Okay.
details here, right? Especially for problems that are relatively simple and pure. There's a lot of these more quote unquote lower level
Yeah.
ideas they can ask you on. Okay, so just be aware of this kind of preparation. But overall, I think the communication
Mm-hmm.
part was
Okay.
actually
For
fine
sure.
there. It was just a confidence thing. But your communication, your answer was actually correct. You just got juked out there. So it's just a
Okay.
matter of preparation that one.
Yeah. But I felt like when I was
Yeah,
explaining like the stuff up here,
yeah.
so like there I was like kind of stuttering. I'm not sure if I got the point through. I'm not sure if you were
Yeah.
following along to what like I'm saying.
So yeah,
I
I
feel
see what you
like
mean. I would say
mhm. Yeah.
there's two things to address. The first thing is that you are explaining this to someone who knows all common solutions to the problem. So you're not explaining this to someone who is in
Right.
first year who doesn't know anything about this kind of stuff, right? So you don't actually need to explain
Uh-huh.
everything, right? You should explain it to a level where the
Okay.
interviewer
Okay.
has confidence that you understand what's going on, right? So it's not the same standard. That's the first thing.
I
The
see.
second thing
Okay.
is, yeah. So my perception of your explanation was fine. There were a couple things that probably could have been improved. I'll give you an example. An example is
Hmm.
I think this is very good to write out the power tower in this case, and that's very intuitive, and it's very good to write it out this way. However, right, I had to ask
Yeah.
you what is the base case for you to realize that we need to subtract one for its odd, etc. Right? Because look, the example you gave was very kind because
Okay. Yeah.
you
I
start with a power
remember.
two. If it's a power two, then
Hmm.
obviously it all divides
Yeah.
by evenly, right? But if it's not a power two, then it has to have odd.
Yeah.
It has to have an odd quotient at some point, right? So keep in mind
Yeah.
that if you write
Yeah.
yourself an example because it's convenient to show something, which is nice, that doesn't necessarily represent all inputs, right? So just be aware of this fact in the future.
Yeah.
Because
Yeah.
you know
For
the
sure.
obvious follow-up question is like, oh, what if it's 2 to the power
Yeah.
of 9? Well, then what do? You can't divide by 2, right? So just be aware of that.
Hmm.
Okay,
Hmm.
great.
Yeah.
Any other
Okay.
questions about the first one? I want to
Sounds
move on
good.
to the second one if not.
Yeah. Yeah. We can
Okay,
go.
great.
We can move on.
So a couple of things here. Let me just look at my notes. So first of all, I want to comment on this. I want to applaud you on the efficient note taking, right? This is actually a quite important skill, which I think you have down quite strong, and keep it up because there's two things I see people get stuck on a lot in terms of wasting time. The first one is asking questions about the problem that were already answered or were already said, right? That's a
Hmm.
bad luck because that means you just don't know what's going
Yeah.
on, and also because it's wasting your time, right? If it's a purposefully vague prompt
Yeah.
which requires clarification, then it's obviously good to ask, right? But oftentimes, especially this level of
Yeah.
problem, there's no ambiguity. It's very objective. There is a correct way to proceed. So the efficient notes here are good. The second thing here is that it was good that
Hmm.
you
Okay.
checked if you should proceed with the implementation of the naive recursive algorithm because I'm not sure if you knew this, but if you had done that, you would not have had time for the DP solution because just the mechanics of writing out all of
Right.
the if statements is just going to eat up all your time. So it was good that you checked because that also
Right.
allows the
Yeah.
interviewer to essentially say what they think, which is that, oh, I think that you're good enough to just go think of a better solution because I don't think you would have issues finding the recursive solution anyways. So it's good. So I'm saying is it's good that you asked
Hmm.
about whether or not you should implement or find a better solution. This is a
Right.
pretty
Okay.
basic DP
Right.
problem. This is probably one of the most basic DP problems that you can 2D most one of the most basic 2D DP problems you can come up with. But regardless, it's still good that you came up with the intuition,
Hmm.
right? And so something like this is a very positive signal for the interviewer
Yeah.
because it signifies that you saw the brute force case, and then you also found a relatively straightforward optimization on the same principle. So the strong DP intuition here was good, and spending
Yeah.
the time to slow down and write the example with the numbers was also a very good use of time. two things, right? First of all, that aligns you and the interviewer, so that you essentially bring them on as a stakeholder for your idea. That's a good thing. The second thing is that it makes things visual, so that when you want to go back and run a test, either mentally or actually a real test, it gives you something to base it off of. So it's a good use of time, and I think that was well done. Um, what they hear, which was quite interesting as well, which I think it was fine, was quite good, was that you used the sentinel row and column. The max or use the max values on the bottom and the right side, right? Just so you don't have to check the edge
Yeah.
cases. That's fine. That's good as well. Um, I
Yeah.
would say that in general, right? One thing that quote unquote causes is it causes you to be locked into the full 2D memory space, because you are always thinking about how to use,
Mm-hmm.
like your loop is always basing it off of the full 2D space, which is fine. It's correct, right? But just keep in mind that
Mm-hmm.
quote unquote relative ease, you can make a pretty easy memory optimization, right? So just be aware of that.
Yes. Yes,
And
for sure.
in general, I would say for array questions, grid questions, in C++ at least, since you can copy by value directly, it's good to ask, hey,
Yeah.
are we allowed to overwrite the grid? Are we allowed to do this and that? Because for example, if you asked that and I
Yeah.
had said you were allowed to overwrite the grid, then you can use zero extra memory by just overwriting the grid with the cumulative best sum, right?
Yeah.
So that's
Yeah.
something you can just generally ask
I
ahead of
agree.
time, just
Yeah.
in case. Very very quick, throw it out there, not an issue. Most of the time they won't let you do that because that's cheesing it, but it's not
Mm-hmm.
harmful to ask. So yeah. Um,
Yeah.
yeah, any
Yeah.
questions about that one? I think overall communication on the second one was fine as well. So I think it just comes down to being confident in your solution, and
Mm-hmm.
that would solve a lot of the concerns there, I think.
Mm-hmm. Okay. Yeah. So it seems like I feel like at least for these two questions, as you said, they're like kind of easy
Yeah, they're
mediums.
easy mediums. Yeah.
Yeah. So I feel like yeah, yeah. So I feel like I'm able to do them, but I guess like for more
Yeah.
harder questions, like I not like there's instances where I will get stuck,
Yes.
right? Um,
Generally speaking,
what do you think I should like do in those
yeah. So
scenarios?
there's two kinds of communication. There's the first kind, which is preemptive, which is when you explain your solution, you explain your thought process, etc. And that usually happens if this question
Yeah.
is easy for you and you already solved it, and everything's good. The other kind of communication is a collaborative communication, and that's when you are stuck on a problem and the interviewer is helping you along, and whatever you say in that context, I would classify as collaborative communication, and that's a completely different skill.
Hmm.
So, I mean, to answer your question directly, what do you do in
Okay.
what do you do in that case? Well, you have to practice it, right? And frankly, the only real way to practice that kind of communication is by doing mocks. Either you can sign up again, or you can get your friends, etc. You can't really do it by yourself because you just see the solution, then it's like, yeah, that's really the only way to do it.
Right. Right.
However, I think there are a couple things that you can kind of prepare ahead of time for that, right? The first thing is by having common phrases you would say for if you're stuck by a specific thing. So, for example, let's say you're doing a 2D DP and you're not sure what I call it the DP invariant. A DP invariant in this case is what you have written here, right? You can prepare a
Okay.
phrase for,
Yeah.
I'm currently thinking about this DP optimization, right? I'm doing, I know that we need to compare these two values. I'm not sure how to combine them, right? Thinking about things that you can prompt for a
Hmm.
relatively small and contained piece of information that the interviewer is more inclined to give, right? Like what's not good is say,
Okay.
"Oh, I'm stuck. I don't know what to do." That's very that's a bad signal because that also signifies to the interviewer that you don't know what you don't know, right? While if you were doing a problem such as this problem and say, "Oh,
Hmm.
I know this is the right way forward. I'm not sure how to compare these two values," right? That's like a more direct and
Yeah.
specific piece of help that the interviewer can give. So that's the first thing, right? Know what you don't know and be specific with what you're asking. And the second one, generally speaking, I mean, like
Hmm.
that's the main one. If you can do that, that's generally very good already. And the second one I would say comes down
Okay.
to taking the time for yourself. So you said earlier that I'll take a few seconds to think about this. It's okay to take more time than that. It's okay to say, okay, look, I'm not sure what my next step will be. I'm gonna take a minute here and just collect my thoughts and just write out some notes for myself, and actually write out notes for yourself and for the interviewer to let them know, here's what I'm thinking, here's the thoughts I have, right? Here's an idea I have, here's what I think it will or won't work. Here's another idea I have. Here's idea 1, 2, 3. Here's a pros and cons for each. Right. I'm not sure how to proceed. Collect some of these paths forward, and then say, okay, look, I've got these 3 ideas. I'm not sure which is the best one to continue with. Can you help me decide? Right. So if you don't have something which is specific
Hmm.
to move forward on, or specific to ask for help on, create some reasonable questions, such as which way to proceed, to to at least signify that you've thought
Hmm.
about certain
Yeah.
trade-offs and you're not sure which one is a path forward, which is a much more reasonable question to ask than I'm kind of stuck right now. I don't know what to do, right? So just keep that in mind.
Yeah, that kind of makes sense. Yeah. Yeah. So you would say that like it's actually like in the situations
Yeah.
where like I'm stuck, it's okay to like maybe propose like a wrong solution and then kind of like ask for,
Yes. Yes.
uh, I guess
Yes.
transition
It's
into a
always
better,
possible to
yeah.
say, okay, for example, you could be kind of far down the rabbit holes, but you can say, okay, look, I've gone down this path. Here's my train of thought. I don't think this is gonna work going forward because of this and this and this, right? If it were to back up to this
Hmm.
implementation
Yeah,
I
yeah.
had previously, or this idea I had previously, I think I could make this work by continuing down this different path. What do you think about these 2 options? Should I continue on my current one or should I switch? Right, that's something which is fairly reasonable, and right, and also keep in mind, right, like from the interviewer's perspective, the goal for the interviewer is not to watch someone fail miserably, right? The goal is to decide
Hmm.
should they hire you or not. That's the goal, right? Or should they pass the next round or not, right? Like that's the goal.
Yeah.
And if you're getting stuck on a problem, that's typically not the thing which the interviewer gets the signal out of. Like they don't make decisions based on watching you get stuck there for 3 minutes, right? Like that's not the skill, right? In fact, if you can demonstrate that you
Right, right,
recognize that
right.
you're in a dead end and you can back up to a certain point and then potentially have another shot, that's arguably a more positive signal. So if you are stuck or if you think that your solution doesn't
Yeah.
work, it's okay to fail fast and just back it up and ask.
Okay. Yeah, for sure, for sure. Yeah, that makes sense.
Okay, cool. Anything else?
Yeah, no, I think that's all for today. So yeah, thank you for your time. I appreciate your
Awesome. Okay,
feedback.
well, thank you very much for participating. Take care then.
Take care. Good day. Good day.
Okay. And that should conclude all the mock interviews for today. Let me see what's going on in chat. One person. I wish I got asked problems this easy. Well, it depends where you interview, right? Most of the time, keep in mind that these interviews, the candidate gets to indicate what level of difficulty they're looking for. So some candidates are a bit newer and they want to be asked easier questions. Some candidates are a bit more experienced, and so they'll be asked to ask difficult problems. There was actually a candidate a couple weeks ago I had, which wanted to be tested with a more difficult problem, and you can find that problem on this channel. I think it was the GCD navigation problem. It was a pretty good one. Yeah, but it just depends. What follow-ups would they be asked? What follow-ups do they ask? Oh, are you asking about the first question here? So the power function is pretty interesting, right? There's a naive solution which you iterate through or you recurse linearly through. That's O in time, O in space. And then of course, in the case where what this candidate implemented, they found the first optimization, which was if you had, the logarithmic breakdown. So you divide the power by 2 every time. So that's the first follow-up essentially, is how can you do that? And then there is one more optimization you can make after this one even, which is how do you use less space, and that one requires some more bit math. So that one's quite annoying, but it technically is a possible follow-up, especially if the role is a lot more low-level focused, a lot more math focused. That would be like a more valid follow-up. For general software, for general infra even, that's not a reasonable follow-up because no one cares about that kind of stuff. So, but that in the problem space, that is a follow-up.